inference compute, training on the edge. The compute on the edge could have similar trajectories like the compute in the cloud. The reason for that is that the paradigm is shifting on compute on the edge, which is the ability to do math at scale for inference and eventually for training, but I'm going to come back to that a bit later. The key here is the following. I just visited a seminar here at Stanford, links in the show notes. It's about compute on the edge. And the gentleman showed one graph, which was interesting. It showed the market cap development of Intel versus Nvidia when AI kicked in. And he's saying they're at the same stage now with the edge compute. Edge compute today is not dominated by one company. There's many companies, Texas Instruments, Analog Devices, Qualcomm, Renesas, companies that have been in the automotive space and the automation space for decades. So what we call edge compute is really all the stuff from refrigerators to KUKA robots to cars. There's a lot of compute happening on the edge, but it's pretty stupid compute. It's more like analogous to maybe switches, maybe routers if you're lucky. But there's not a lot of intelligence. And in particular, there's no adaptive agent making decisions based on the environment, which is really what we call AI today. So what we're trying to say here is that the ability to actually deploy that kind of compute is, in our opinion, it's underestimated. Like there is a lot of opportunity in terms of wealth creation, market cap, but also in building mount. And we see Tesla as a company that is actually innovating on that front, and that's very exciting. So the AI 4 and coming AI 5 and 6 chips for the cars are case in point. We see more interesting developments also on the robot side. In fact, a lot of the robots business, in fact, is going to come down to compute. It's not just compute like the car. You're going to have to build actual metal that can work and doesn't fall apart and all that. But the compute is going to be key. We need high precision, high performance, low power, reliability, robustness for inference compute. And the more complex the models become, if you want to have large language model type reasoning at the level of an Optimus, you're going to need a lot of memory. You're going to need a lot of compute and availability of that type of stuff on the edge so the agent can make decisions. You can't rely on the latency of a network, and you can't also rely on slow compute. You need fast compute, and more importantly, also you need accessibility of memory. If you want to do something like large language models, you can do distilled large language models, for example. So there's obviously ways to do that. But my point here is that I think we see an opportunity for massive wealth creation for Tesla, not just in building the cars and the robots, but also developing the compute for those machines. And I think that's a bit underestimated in the current discussion about Tesla and in general also about the robotic space.